Hi everyone, this is Dr. Swaminathan Yasyam. Now I am going to discuss about the topic called differential equation under the linear control system unit 1, control system modeling. So first differential equation and integral equation. Differential means what? And the higher parts that is divided into lower parts, that is called a differential equation. So the previous class review, that is first one, we will discuss about already we discussed about the closed loop control system versus open loop control system. So next, the differential equation and types and ordinary differential equation, first order linear and ordinary differential equation, Bernoulli equation, second order ordinary differential equation, and the boundary conditions and the initial value conditions, and higher order homogeneous order of differential equations, applications, examples, Laplace, heat and wave equations. So the first differential equation, there are types, ODE, ordinary differential equation, partial differential equation means dou, that symbol is used, linear differential equation, non-linear, homogeneous, non-homogeneous. Homogeneous means same, non-homogeneous means different, that is called homogeneous equations, non-homogeneous equations. So here the ordinary differential equation, that is a simple example, dy by dx plus 5y is equal to e power x, exponential power x. So dx by dt plus dy by dt equal to 2x plus 5. So partial differential equation, dou squared u by dou x squared plus dou squared u by dou t squared is equal to 2 dou u by dou t. Dou e by dou y is equal to d dou v by dou x. So the first order and second order and higher order differential equations. So the first order equation, y dash equal to function of xy, and dou y, that is equal to function of x comma y, and dy by dx equal to 2x plus 3. These are all the first order equations. And the first order linear differential equation, that is linear ordinary differential equation, dy by dx plus px of y equal to q of x. That is called the integral factor we will use to find the constant c. And the exact equation, that is m of x comma y plus n of x comma y into dy by dx equal to 0. So dou f by dou x equal to m, that is dou f by dou y is equal to n. So these are all called the continuous equations. So that is exact equations. Next to the separable equation, that defines separable equations, that is differential equations. We will discuss n of y into dy by dx is equal to m of x, and n of y into dy, that is equal to m of x into dx, that is the cross multiplication, that is separable differential equations. Next to the Bernoulli equations, that is called y dash plus p of xy equal to q of x into y power n. So this is called the Bernoulli equations. So p of x and q of x, that is the continuous functions on the interval. We are looking on the n is a real number, and the differential equations, it's called the Bernoulli equations. Second order means that is double differentiation. So y dash means single order, that is first order. Y double dash means the second order. So p of t y double dash plus q of t y dash plus r of t into y is equal to g of t. That means a y dash plus b y dash plus c y is equal to g of t. So differential equations homogeneous means when g of t is equal to 0, and when g of t is not equal to 0, that is called the non-homogeneous. And next to the second order activity, that is y double dash minus 9y equal to 0. So that is second order differential equations. So the activity, we will discuss about the connections which start with the word yes. So continuously you can make if one word completes, for example electronics means yes, completed. So start with another word, yes, system. Next m, that is another thing, manufacturing. So like this we will have the connections for activity. And next to the initial or boundary value problems. So finding the temperature of all the points in the iron bar, that is absolute, and freezing point will be the boundary value. So starting range and the end range, that is called initial or boundary value problems. So the boundary conditions y of x, that is y of 0 is equal to 0, y of pi by 2 is equal to 2. Without the boundary conditions, the general equation is a sine of x plus b cos of x. The boundary conditions, that is just apply x is equal to y of 0 is equal to 0, a into 0 plus b into 1. So cos 0 is equal to 1, sin 0 equal to 0. So you can get the 2 equal to a into 1. So a is equal to 2. So you just substitute the value, y of x is equal to 2 sin x. That is called the boundary value problems. Next, for example, y cube minus 5 y double dash and minus 22 y dash plus 56 y is equal to 0, y of 0 is equal to 1, and just substitute y dash of 0 is equal to 2, y double dash of 0 is equal to minus 4, based on the previous applications. So similarly, the above equation, that is higher order non-homogeneous differential ordinary equations. So what are the applications? So modeling with the first order equations, we will derive the Newton's law of cooling, electrical circuits, so free mechanical oscillations, no damping or light damping or heavy damping, and modeling with the oscillations and the activity. So the partial differential equations, therefore known as 2uxx plus 1uxt plus 1utt plus 4ux equal plus cos of 2t is equal to 0. So you can get the example of non-linear PDE, that is the linear and non-linear PDE, partial differential equations. That another example is called Laplace heat and wave transform. Laplace transform means I can get the dou squared u xy dash divided by dou x squared, next to y squared, next to z squared. So based on this, we will derive differentiate, that is three different term x, y, z. Next, the heat equations, that is ux, y is T. It's used to represent the temperature at the time constant T in a physical body at the point that coordinates with the three axes, that is x, y, z. So alpha is the thermal diffusivity, and they are sufficient to consider alpha is equal to 1. So dou u of x, y is T by dou tt equal to dou into dou squared u by dou x squared plus dou squared u by dou y squared plus dou squared u by dou z squared. That is called the heat equation. We just derive the three different parameters. U is a common one and x, y, z is varied based on the dou. And the wave equation, that is also based on the squared format, and dou squared u by dou x squared plus dou squared u by dou y squared plus dou squared u by dou z squared. So the function u of x, y is t, so to represent the displacement at time t, the particle whose position address the x, y, z. This is called the wave equation. That's all. Thank you.